Hello, today we're going to be looking at Leetcode problem number 1650, which is the lowest common ancestor of binary tree, third problem in the series. We've already looked at problem number 236, which was also on finding the lowest common ancestor of binary tree. The difference was that here in 236 we were given the root of the tree, and along with that we were given the target nodes P and Q. While here we are only given these nodes, okay, and we are expected to find the lowest common ancestor. Now let us quickly revise the definition of lowest common ancestor. What the definition says is that if you take two target nodes, let's say 5 and 1, then what is the lowest parent to these nodes? If let's say 3 had a parent and then that parent had another parent, then who is the lowest, or rather which node is the lowest parent to 5 and 1? Now here in this case 5 and 1 are on different subtrees, but imagine if they were on the same subtree, like for example 5 and 4. Then in that case we have to return the topmost target node, because a node can be lowest common ancestor as well. So this is the background, and what we did in problem number 236 was we followed the recursive approach, where we looked at the left recursion and the right recursion, and we saw that if there was a node return on either side, then the current node had to be the LCA. If not, we looked at if the left had returned something, then we just propagated that. If right returned something, then we just propagated that. Now, we also hacked it a little bit. Feel free to review the code or that previous recording to see how that exact execution was done. Now, let us start thinking about the current problem, where we are not starting from the root node, but rather starting from the target node itself. So what is different is that apart from the value, the left and the right, we are also given the parent. We are given the parent link. All right. So the approach that we will be following is that what we will do is we will look at the subtrees of one of let's say P. Okay, so we will do this for both P and Q. So let's say we start with the target node P. We will look at its subtrees and we will say, do I have Q in the subtree of P? Okay, if I don't have P in the subtree of, if I don't have Q in the subtree of P, then I can move up. Okay, and now I am already on the path of P. So I am going upwards from P. So I know that P is definitely there in the subtree of 3. Now from here, I want to look at the subtree of 3 to see if Q is there. Now we have already processed this path, so I don't want to process this, but I definitely want to process this path to see if Q exists in this. If Q does, then this will be my LCA. If not, I'll go upward. Now the same has to be done for the Q's path to see if I can find it. And let's say if I keep moving upward from P and I keep moving upward from Q and I don't um, um, find a subtree that is like basically what I'm saying is that if I get to a point where they both end up at the same parent, then this is the lowest common ancestor. That is another option. So these are some of the few options. We will have to code this up now. Let's think about how we will be coding it up. The first thing is that I will be using so one more thing to highlight is that when from P I'm moving upward to its parent. Like I said, I have already traversed this subtree, so I don't want to process this again, right? I just want to process this. So what I will do is I will maintain a variable to state like what is the node that this parent has to skip processing. Okay, so I will maintain a variable. I don't want to keep a list of all the nodes that have been visited. That is totally useless because I will always check with the immediate children of this parent, and this parent will only have two paths, right? And we have gone up to that node from one of the paths, so we just need to maintain the latest node in one of the variables for me to identify the path that I have to skip. That is another point that I wanted to share. And okay, let's quickly look at what the pseudocode looks like. So in order to search for the nodes, I will have to do the tree traversal. So first thing that I need is a helper method, which is a traversal method, and I have called it is LCA. So what this looks like is this will be the current node from where you're starting lookup. Like for example, you could be starting lookup from 5, you could be starting lookup from 3, and while we are starting from the target node of P, we are looking for Q on, let's say if I'm here, then what I want to do is I want to search for Q in these subtrees, right? So those are the two things. I have named the current node as LCA node, and so what I'm checking is this the LCA node? Um, Maybe calling it an LCA node is not the right thing because it's not yet an LCA node. So let's just call it current node, and then maybe I can call this as the target node, and then I can also have checked, which means I've already checked or visited, which means I've already visited or checked a particular node and its subtree. So we want to skip that. So let's have this like this. Okay. Now what I want to say is if not current node or not target node, that means one of them are not there, then I can never find anything. So let's return false here, and then let's do a breadthwise traversal with a Q, and I say Q dot append. For me right now, I'm starting with the current node. Okay, now I start my traversal and I say while len of Q is greater than 0, okay, I will get another, let's call this as node. So I'll say node is equal to Q dot pop of 0. I get that. And then if this node is equal to checked, okay, so here we are checking for the exact instance. To be super safe, what we can do is check for the value. So we can say if node dot val is equal to checked dot val, that means starting from here I came to one of its child. I have already visited I have already visited the node 5. So what I was saying, sorry, the pointer was not active. So what I'm saying is starting from node 3, I would have added node 5 and 1 to the queue, and 5 is already checked. So I want to skip processing this, right? So I'll say continue. Okay, and then next thing to check is if I have found a target value. So if node dot value is equal to target node dot value, then what you can say is I found it. Let's return true. All right. Now let's say I have not found it, then I need to keep looking in downwards. So if node dot left, if it exists, then you add it to the queue. Okay, same way if node dot write exists, then you add it to the queue. Okay, so once you've added all of this and all of this traversal is over, and then there is nothing left in this queue to process, that means we could not find the target. Let's return false. Okay, so this is the traversal code. I am just gonna keep the definition and go ahead with the main. Okay, so now what we have defined is LCA, which takes the current node, which takes the target node, and it also takes the checked node, and it returns a bool value to you. Okay, now this is already done. So now let's go to the next part. Now what we want to do is we want to iteratively keep moving upwards. Okay, and so the current variable that represents this node at a particular time and at another time this node, let's start defining those variables. So let me call this p node, which is the values that I am traversing, or rather the nodes that I'm traversing on the p path. Okay, so when we start, it is pointing to p, and then I have q node. When we start, it is pointing into q. Okay, so let's also define p checked, initially nothing, so I have not checked anything on this side, and q checked is also equal to none in the beginning. And so what I can say is that while p node and q node and p node dot value is not equal to q node dot value. Okay, so till the time I have not landed on the same parent, let's continue traversing upwards on both p path and the q path. Okay, so first what we do is we take the p status, which is LCA. You take the p node, which is the current node. You're looking for the target, which is q, and you have already checked this particular node on the p path. Okay, all right. So what I was saying is that here is the p status, which we're getting by traversing the starting from p node, looking at its subtree, trying to find this target value, or rather target node q, and I have some checked values. There seems to be some issues with the connectivity of the remarkable app today, but let's hope I'm able to cover this video without any further problems. So once we have received the status, it can either be true or false. So let's see what does that mean. If the status is true, that means we found Q. All right. If that happens, we return the current node as the LCM. In case we could not find Q, now we have to go up. Okay, we have to go up, but I update my p checked, which is equal to p node, because I just traverse the subtrees of this node, so this is definitely checked. Okay, and what I say is that p node goes upwards. Okay, dot parent if it exists. So if p node dot parent, else just stay as it is, because q will catch up. Okay, so this is the part block that will repeat for q as well. So you will have q status is equal to, I'm going to skip this, and what's going to happen is that when this while loop terminates, you would have come to a point where both P node and Q node are at the same node. So at that point of time, you can just return the P node. That is it for this problem. Hope you liked it. Thank you. Bye.